Yep, so welcome to this video, and we are going to continue with where we left in designing our payload. As you can see, I have a schematic that we designed in part 1 of this payload design structure. So we have our main controller, this STM32F407 VGT6, because it has a digital camera interface and an FSMC in case we need to add an LCD, right? So in this part 2, I'm going to add the camera symbol and circuitry so that it's visible of what we are designing. So I have opened the OV66, 7670 schematic. Let me open it, the datasheet for that particular camera, and I'm going to show you what is needed for successful connection to the STM32. So this is the camera I'm designing for, and it means that we need to route, or rather connect, all of these pins to the STM. So these are the features of the camera. If you go through the system requirements for the payload system, you'll realize that this is what I've listed on the system requirements. Basically, it's going to capture VGA. VGAs are pictures with this resolution 640 by 480, which is basically 4:3 ratio, width and height. Also, it has RGB ability, obviously, color pictures. It can stream up to a maximum of 30 FPS. Though it's not listed here, but it has that 30 FPS streaming, which means it can capture video. It can also be set to capture still frames without any issues. You can control the quality of the output, see, directly from the camera. It supports scaling, so you can scale the camera, you can crop the camera image. There was something else listed that it consumes around 60 milliwatts of power in active mode, right? Yeah, here it is, 60 milliwatts of power in active mode. That is 15 FPS VGA in this format, and then less than 20 microamps in standby mode at 3.3 volts. Right, so maximum image transfer rate is 30 FPS. Those are some of the features of this particular camera, and then this is the block diagram, right, showing the connections for that particular camera module to the host controller. The host controller in our case is going to be the STM32. This is I2C, obviously, SCL SDA, and then we have href at VSync. So href at VSync and pixel clock are provided by the dedicated multimedia interface, digital camera interface at the host, right? And then there is an 8-bit, this is a 8-bit plus parallel camera data communication from the camera to the host, then power down and 3v3 and some other signals. And you have like a master clock controller here to synchronize the frames and everything on the camera, right? So if the data sheet here says that if the host does not have a dedicated camera interface, we can use what is called an accelerator buffer or an external frame buffer controller, like this one, because the camera is too fast. And for these MCUs that are slow, right, we need need to buffer an entire frame before we read them out with low speed MCUs. So this is a different mechanism or structure, all the same, but we don't want to use this because number one, it adds the hardware costs, number two, it increases the complexity and more points of failure. So I'd rather we go with an MCU that has an inbuilt DCMI, right? And also next is just a number of pin descriptions that you'll look at and dimensions, etc, etc. So this will be helpful when you are designing the footprint. I've not found a footprint on EZD obviously because this is a module, so I don't know, I've not been successful in finding one. The one that is available on SnappyDA, is it? Yeah, SnappyDA. There is none that is there for EZDA for some reason. So yeah, we'll have to create one ourselves. Okay, so what I'm gonna do, I'm gonna open this payload schematic. So the first thing we need is a symbol for the camera. And again, yesterday I said that we are designing with the help of the STM32Cube IDE. So there are some routes or pins I rerouted from USAT 1 to USAT 2 for debug. So PA2, I'm just gonna route that. PA2 is USAT 2 TX. So I have that. TX is right here. PA2, yep. PA2 is PA2 is it? Should be available around here, yeah. TX and RX. So just confirm again, P3 is RX. Just connect those two like that. The reason why I did this is because these other pins, these PA9 and P10 are being used by something else, by the FSMC controller, if I'm not wrong. Yeah. So that's that. Next is we can now route the camera, right? But we need to create a new footprint. I mean a new symbol. So go to File, new symbol, new component. Okay, so I'll call it OV67670 module. Personal. Okay, save. Let's see. Okay, so let's try to create this footprint really fast. Let's see, is it here really? Pin wizard. Okay, no, not the wizard. Okay, so I need a rectangle like that, right? Let me open the pinout. This is the pinout I'm following, so I need this rectangle here. Like that. So this is going to be on the right side. I need 1, 2, 3, 4, 5, 6, 7, 8 pins times 2, 16. So I need 16 pins. That's 1, 2, 3, 4, 5, 6, 7, 8. And then you can see I'm naming them counterclockwise, 13, 14, 15, 16. Okay, so it's not even that big, so yep, that is enough. And then next I'm gonna move this rectangle somewhere there. Okay, so the first pin is this D1. So I'm gonna pin name is gonna be D1. This is D3. This is D5. So I'm just gonna create all of them at once. D5, D7. PCK. VS. This is VS. This is SEL. Pin name. Okay, yeah, SEL. This is 3v3. V3. Number 9 is ground SDA HS. So this is ground. SDA is right here. HS is called the horizontal sync. So I'm just gonna call it H sync. I'm not wrong. Yeah, this is vertical sync. So V sync, just for like consistency, right? XCK here. So XCK is a mean clock. So this is gonna be called MCLK. And 13 is D6, is a 8-bit parallel data. So D6, D6, D4, D2, D0, just the even ones. D6 and D4. This is D2. D2, this is D0. Okay, so that's fine. And I can put some text here to say this is the OV7670 camera module. Place that here, just like that. Font symbol. Let's put it inside. Okay. Save font symbol. Canvas origin doesn't fit inside the graphics. What? I don't know what that is, but canvas. Anyway, okay. Let's see whether we can access it from this side. If I go Shift F, I go to personal, I should be able to see it somewhere. Yeah, here it is. So I can place it. Right? Yeah, cool. So we have the camera here. Let's place it somewhere here. Okay, so pretty basic stuff. Ground. We start by the ground pin. So I'll wire it directly like that. Let me pull it that way. Then 3v3. Copy this one. Put it somewhere here. Right. SCL and SDA. So that is going to be connected. CL and SDA. This is SDA, and this is SCL. Right. So I'm just naming all of them as they follow each other. And then later we'll like distribute these pins to either to both the MCU and to the connector of boot connector, right? So that and that. All right, so this is D1, this is D3, D5, D7, PC what? Okay, this is VSync. Okay, and I'm gonna like label these others. So SDA is already labeled. It's sync. Let me just place them like that. This is H sync. This is master clock CLK. This is D6. This is D4, D2, D0. Okay, so that's okay. Let's connect them to STM32. So go back to Cube ID. I'm going to be using I2C1. Enable I2C. I'll change the configuration settings later, but for now PB7 and PB6. But the problem is these two are, if you look here, they are connected to DCMI's VSync, right? And this is connected to DCMI D5. So let me change that to I2C1. I2C3. Let's see 3. What is connected to 3? Where is it? P8 and PC9. P8 and PC9. What about this I2C2? Let me disable I2C3. Sometimes when you have like such conflicts, for example, this, you can't access the Ethernet MAC with DMA if we use I2C2, right? But there are ways like you just choose which one does not affect other. But because I'm not using Ethernet, I can go with I2C2. There's no problem, right? So I'll go with I2C2, PB10 and PB11. So PB10 is SCL. PB10 is SCL. So we come back here to EZDA, look for PB10 right here and PB11. We label that. We said 10 is SCL, so this is SCL, and I2C2, this is PB11 SDA. So since these are I2C pins, they need to be pulled up to 3.3 via 4.7K resistors. So I think I have 4.7K somewhere here. I'm gonna find that to reuse it. Where is it? 4.7K. Okay, here it is. I'm gonna take that, bring it here. 1, 2. Yeah, like that. Oh, no, let me put it to avoid shorts. I'll put it right there, then just arrange these a little bit. from this point to this point, then here and here, right? Or let me put them, let me put them there. Cool. So we save that and then we pull them high. We pull these high, so connect like that, connect like that. Okay, that I2C is handled. So I2C is handled here. There's a pin I left, I think. There's a power down pin. Oh, it's grounded, okay. According to this module, it's grounded. This is not even available. It's not broken out. It's grounded internally. And reset. There should be reset somewhere. Funny, there's no reset. Anyway, yeah, we'll check with the module you buy whether there's reset or not. But these are 16 pins. These are 16 pins. So I think everything else is handled correctly on the module. We'll recheck. I can't assume that. So the next thing we do is connect the DCMI. This 8-bit parallel stuff, right? So we start with the VSync. So if you go to this cube, go to PB7. PB7 is right here. So this, you realize this is DCMI VSync. So I'll set it that way. Enter user label. I'll call it PC. I'll call it camera VSync. Right. This is PB7. So back here, we look for PB7. Where is it? It's right here. So wire it to just gonna wire it to, call it camera, no, call it VSync. Right, this is what I've named here. I've called it VSync. Okay, VSync. Next is PCLK connected to PA06. PA06. Where is PA06? PA6 is somewhere down here, I think. PS6, yeah, DCMI pixel clock. Right, so back to EZDA, we're gonna call that PCK, right? That's PS6. Look for PS6, it's right here, paste this. Paste that right there. Next is what is called the master clock. So master clock is connected to PA08. PA08. Or PA8. Where is it? It's up here. So you realize this MCO is master clock output. So what happens is that we need to provide an external oscillation signal to the camera module. But the STM, the good thing is that the STM provides us with like a pin we can tap the crystal, 24 megahertz, 16, whatever we choose. So this is why it's called master clock output. Main clock output, not master. Yeah. So this, I'm gonna call this MCLK, not PM. MCLK, P8 MCLK. So where is P8? It's on this side, I'm sure. Yep, P8 is right here. Connect that to MCLK. All right, MCLK is right there. So cool. Next, so we are done with those, most of them. Next is what we want to do is H-Sync. H-Sync is connected to PA4. Let's look for that here. PA4, where is PA4? PA4 is right here. This is DCMI H-Sync. So I'm gonna call it what, camera H-Sync, right? Camera H-Sync. I should rename these others also too. Camera PCLK. But let me connect the H-Sync first. So H-Sync is, I copy this, come back to PA4. PA4 is right here. We put that there. Let me move this 3v3 a little. Paste it here. Right, H-Sync is right there. Okay. Next is what? Next is the data, right? So these data pins, where are they connected to? So for example, D0 is connected to PC06. D0 is D0, this one, PC06, PC06, D0 is PC0, no, it's PC08, PC08, here it is, paste that as D0, confirm down here, PC8, PC8 is DCMI D2, not yeah, D2. PC8 is DCMI D2, okay, and then PC6 is DCMI D0. Yeah, so that's correct. So yeah, enter user label camera D0, enter user label here camera D2, camera D2. Okay, so let's connect this. As D1 is connected to PC7. Yeah, so camera D1, D0, D1, D2. Let's connect these three: P6, 7, and 8. P6, 7, and 8, right here. So P6, P7, P7. Wait. Paste. So we have said PC6 is D0, PC7 is D1, PC8 is D2. Right, now D3 is D3 connected. D3 is connected to PC09. Confirm that again. D3 is right here, so this is gonna be called camera. Camera D3, PC9. right here. Oh. This is D3. Right, D4 is PC11. It's right here. Delete this. This is PC11 is D4. D5 is PB6. So I've mapped this out before, so I'm just referring them to them so that it becomes easier and faster to do that. PB. D5 is PB6. Where's PB6? Instead of looking for it here, I can also like look for it here on the system GPIO. No, that's fine. Let me look for it here. PB, I'm looking for PB B6. PB6. Is it not broken out? 12, 13, 14, P10, 11, 0, 1, 2. Here it is. So this is PB6 is D5. Again, we confirm from the STM32 cube. PB6 is right here, D5. Okay. So enter user label this camera D5. D6 is PC06. I think we have connected that, haven't we? We have not. D6 is PC06. So I look for that pin. No, it's P08, I think. Yeah, 08, PC8. Where is PC8? Let's look, let's see. PC8. These pins they're not very many, but they're kind of. Oh, it's here. PC8 is not labeled. PC8 is should be D6. Yeah, let's confirm here. PC8 is where is PC8? Four fives. Is port E, or I have activated it. It's right here. D2. Why am I mixing this? PC8 is D2. Okay. So PC11 is D4, which I think we have already assigned, or not yet. So we have 0, 1, 2, 3. We don't have 4, which is PC11. We have 4 right here, we have assigned. Then 5 is right here as it's supposed to be. Then we go to 6. 6 is, this is PC. Let's look for 6. I have an image here. D6, just a minute. It's PB8. Really? PB8. Yeah, PB8 is DCMI D6. Cool. We found it. So D6. Okay, that's PB8. All right, so update it down here. PB8. Here it is. That is gonna be D8. D8 or D6. D6. Then D7 is PB9. So PB9 is right there. Camera PB, camera D8. Camera D8 is PB9. Okay, so I think we had, is it D8? Let's see, PB9, D7, Jesus, D7. This is D7. D7, there's no D8. It's 8 bits. I was wondering. Yeah, so I think that's all for this camera interface. One thing I should add is like a capacitor to ground, just for completion and to make sure that it filters noise around that place. So I'll take 100 NF, put it next here, so I'll filter out this high signal to ground like that. Right, so yeah, save it. What's up with this thing? Okay, let me save. Let me just restart the schematic and try connecting this part here to this part. There should be a capacitor here, capacitor to ground like that. All right, so this is the camera, right? The camera module that way. Okay, so yeah, this is what we were to do in this video, interfacing the camera from the module to the DCMI pins of the STM32 MCU. So in part 3 we are going to now do final additions like user buttons, and then add the connector interface, add the screw holes, design the footprint, is TC. So yeah, we have not done much in this video, but it's substantial to show how we route that camera to the STM32 via checking the cube ID. So we realize these are like orange. This is orange, I think. Yes, so it means they are not like completely initialized as they should, but we'll check that in the next one. Yeah, so that's all for this one, and all the best.